All right, today, our goal before, what is it, 150? I don't even know, regular 155. All right, we want to review domain and range. We want to review transformations to things that are basic graphs. And we want to review how to solve different equations algebraically. Did I open the right one? You guys have the same as me? Yes. Tonight's homework is all multiple choice. Okay? So it's easy to check your answers. But the process, that doesn't mean, and a few true false. Okay? A true statement can just be true. If you think it's false, then it will say justify why you think it's false. Okay, so it's not just false, it's false because blank. I would encourage you tonight, when you get to your homework, to Google things you don't remember. So for example, they'll say, which of the following functions is a one-to-one function? True, like. So the first Google question would be, what is a one-to-one function? Okay? And then just, oh yeah, right. Okay, I remember what a one-to-one function is. So anything that comes up and you're like, I know I learned that in Ham last year, but it's not clicking. So yeah, literally Google the questions. Don't Google the question itself, but Google the topic and see. It'll only take you, 10 or 15 seconds to look at it. Be like, oh yeah, okay, I remember. But give that a try. It'll say, which of the following is in point slope form? And you're like, point slope form, okay, Google. Siri, what's point slope form again? And then have to take a look at it. All right. So let's talk about domain. The domain, when we're defining a function, the domain is, so that would be our first fill in the blank here, the set of x values for which the function will give us real, not imaginary, y values. Okay, I like to think of this like an exclusive club that you're trying to get into, and there's a bouncer at the door. And the bouncer says, it determines who can come in and who cannot come into this club. All right, so maybe the rule is simply you got to be 20, this is a 21 and older club, so there's somebody checking ID. Okay, maybe it's a teens only club, maybe it's a whatever. Okay, that you have certain requirements you have to meet before you can come in, and the bouncer's job is to let the right people in and keep the wrong people out. So a domain is like that, who's allowed in, so that we don't break any of the fundamental rules of math. And there are 3 fundamental rules of math. Thou shalt not ever in a math class blank. So let's talk about what some of those are. You may have peeked at them already, but can anybody think of one? It's on the next slide. Divide by 0. You should never divide by 0. Okay, so your job is to stand at that door and say, I cannot let you in because if I let you in, it would cause me to divide by 0, so I'm excluding you. Okay? So that's one of the first ones. Okay, even roots. Those are square roots, quad roots, roots to the 6th degree, roots to any even root can never be negative. All right, the square root of -4. Okay, now that would produce what kind of answer? Remember? Imaginary. But our goal is only to produce real answers. So I cannot do the square root of -4. I can do the cube root of -4, but I cannot do the square root, so any even root. And then logarithms. Logarithms of any kind, they can't contain a negative number or even 0. Can 0 be contained in a square root? Can you take the square root of 0? Yes, but you cannot take the square root of a negative number. But logs can't have negatives, or these are the 3 main. If you know these 3 main rules, you'll get domain right every single time. So let's take a look at some of them. All right, so for the first one, who do you have to keep out in order to make sure you don't break any of the fundamental rules of math? 3. Okay, 3. And you can't let -3 in either. All right, so 3 and -3 both have to be excluded. All right, there's a lot of you can write that in English. Who are you going to let in? All real numbers except 3 and -3. Okay, that would be writing it out word for word in English. Okay, in math, you might write it like this. A scripted R stands for all real numbers. Okay, or cursive R. And then except, do you know how to write that in math? Okay, x does not equal, so except x cannot equal, and then plus or minus 3. So that might be a way to write it. You can write it in English. You can write it in any way that communicates. This is where the communication part comes in. Okay, learn how to write that. All right, x to the 2/3. So let's see if, now the denominator doesn't apply to this. Okay, you shall not divide by 0. I don't have to worry about that. What does x to the 2/3 mean? Go ahead. Okay, it actually means the cube root, which is what kind of root? Odd or even? Okay, odd root of x squared. Okay, is there anything that we need to worry about that would cause us to break any of the rules of math? Well, it doesn't have a denominator, so I don't have to worry about dividing by 0. It doesn't have a logarithm, I don't have to worry about that. It also doesn't have an even root. So if it doesn't have any of those three things, then the domain is all the numbers. Everybody can come in. Okay, this is a totally open invitation. Any number can participate in that question. Okay, in that function. All right, now we encounter our first type of logarithm. Okay, there are many kinds of logarithms. This is a natural logarithm. You can have a common logarithm, which is base 10. Then you can have logarithms of many other integer bases as well. But here's the only rule for any logarithm is that you cannot accept numbers in that would cause the interior to either be negative or be 0. So what number would cause the interior to be 0? Negative 2. So we have to exclude negative 2. Okay, what numbers would cause the interior to be negative? Anything less than negative 2. So what are we going to keep? Everything above negative 2 is allowed. So we can write this a couple different ways. Okay, you can write it in a positive sense, that we are going to allow any real number where x would be greater than 2. Or you can write it the opposite, which would be any real number that is not, negative 2. Any real number that is not equal to negative 2, and any real number that is not less than negative 2. That gets kind of, I feel like it's just easier to write what you can let in as opposed to what you can't. So there are a couple different ways that you could write that. All right, part D. We have to be concerned about what kind of root this time.
Negative.
What kind of root?
Oh, even.
An even root. This is an even square root. It's implied that there is a little baby 2 right there. So this is an even root because it's squared. All right, and so we need to make sure that all even roots don't ever become negative. The interior of that never becomes negative. So is 2 okay?
Yes. Exactly.
Okay, what would 2 cause the interior to become?
0.
And that's okay for an even root. Is negative 2 okay?
Yes.
Okay, negative 2, if I square negative 2 squared is positive 4. 4 minus 4 is 0, that's still okay. The interior can be 0. The interior just cannot be negative. All right, so anybody want to take a stab at it? What can it be? Go ahead.
From negative 2 to 2?
Okay, inclusive or not inclusive? We're including 2 and we're including negative 2. All right, so you can write that a couple ways. Okay, one way to write that is to use inequality signs. You can sandwich x between 2 and negative 2. That's inclusive, where the line underneath includes the negative 2 and includes the positive 2. That's one way to write that. So all real numbers that way. Okay, another way to write that is to use interval notation, which is a bracket that looks like this. Okay. My preference, you'll usually see me use the inequality notation with the x. Okay, the reason I like it is because it's clear that I'm talking about the x variable. With the interval notation, it's not clear to a reader out of context. Is this applying to the x? Is it applying to the y? Is it the domain? Is it the range? What are you talking about? Also, the higher up you get in calculus, if you take this next year with BC or if you take it in college, the brackets start to mean something else as well. So I just tend to stay away from them because they have multiple meanings. So I feel like the inequality is clear. But I'm not going to mark you wrong if you like to use interval notation. Okay. right, any questions so far? See, it's not so bad. All right. E, this is an absolute value. All right, what can we say about the absolute value function? Okay, what is its domain? Who will the absolute value function allow to come in? Okay, all right. Well, again, just go back to, does it break any of the 3 rules of math? Am I dividing? There's no division. Do I have any kind of even root? Nope. Do I have any logarithm? No. And if it doesn't have any of those 3 things, the default is all real numbers are invited to participate in that one. So that's an easy all real numbers. Okay, what do we call F? It's not a logarithm, but it's a cousin to the logarithm. It's actually the inverse of a logarithm. It's an exponential, right? Okay, exponential functions shoot up to infinity. They start really boring. They're just really flat. This one happens to be flat at the number 7. And then all of a sudden it hits that critical point, which has a special name, which we'll learn, and then shoot, it just heads up to infinity. Okay, but what doesn't it have that we would need to watch out for? Doesn't have a square root or any even root. Doesn't have log. It doesn't have division. So since it doesn't have any of those things, its domain is all real numbers. All right, so we talked about domain. What's the next logical thing to talk about? Range. Okay. All right, the range is produced by the domain. Once you've established what the viable domain is, then the range is what's produced out of that. I feel like this is easiest for me to see as a graph. I think of range as how high does the graph go, how low does the graph go, what's the span of the graph. I think of like long-range missiles, right? Like how far does that long-range missile go? So I like to think of this visually using a graph. So there are certain functions I'll need you to not graph perfectly, but just have a mental image of the shape of the graph in your head. So a parabola, she's talking about a parabola. I know what a parabola it looks like in general. I can picture it in my head. Okay, it looks like a U, things like that. So those are the things we're going to talk about right now. So you want to recognize what you're imagining is reasonable, okay, that it makes sense. I'm not going to be grading accuracy of graphs. That's not the important thing. It's the general characteristics of the graph. Okay, does the graph have the right general shape? Is it facing the right direction? Like, okay, if it's supposed to go up, if it's supposed to go down, if it's supposed to go left or right, is it facing the right direction? Okay, does it have asymptotes where it might need to have asymptotes? The only kinds of graphs that have asymptotes are ones that have division. Because when you can't divide by 0, that forms an asymptote in the graph. So you just, as soon as something has division, you're looking for, oh, there's a graph, there should be an asymptote there somewhere. So these are the ones you should be able to picture. If I say absolute value, what do you picture in your head? A V, okay, just there, okay? Now you hopefully know if it's a V that's facing up or a V that's facing down. V's cannot face sideways, okay? Because they fail one of the most critical tests that we have in math for a sideways V. Do you remember what that was called? Vertical line test. Okay, a sideways V is going to have 2 lines, and so now it's not a function at all. We're only talking about functions. So you want to have a V. A square, okay, anything squared is going to be a parabola, okay, a U shape. So you should have that U shape in your mind. Okay, so absolute values, V's. Squares, U's. I'm not going to grade whether your U is the right skinniness or the right width. Okay, I'm going to grade is the U in the right direction, and maybe do you have the bottom of the U, the bottom of the quadratic in the right place. So it's called the vertex. Going with a square would be a square root. A square root. Okay, just like you can't have a sideways V, that doesn't work. You can't have a sideways U either, okay, because a sideways U also fails the vertical line test. Okay, but you can have half. You can have half a sideways U, which is what a square root graph looks like. Okay, a cube. Any idea what that looks like?
That's the one called a squiggle.
A little squiggle. Some people call it a snake. Some people call it a pinwheel. Okay, so a cube. It definitely has a center. And then it's going to come up through that center. a cube root looks very much the same, only it goes sideways. So all of these things, the inverse would be going a reflection to the side. And if it still passes the vertical line test, then you still have so absolute values don't have inverses because when you reflect them to the side, they fail. Squares only have inverses if you take off the bottom half, and that's called a square root. Cubes, if you flip them to the side, they look like this. They still have a center, and it looks like this. So they're more going sideways, okay? And that whole thing exists because that whole thing still passes the vertical line test, so that's what a cube root would look like. All right, an inverse. Let's see. We know that squares are known by their common name, parabola. Inverses are maybe better known by their common name of hyperbola. An inverse is one that has a denominator, so it has an asymptote. So an inverse would need to have a vertical line. I prefer you to use a highlighter or something to show me where the asymptote is. And then your hyperbola has two sides. It has a lower branch and an upper branch like that. We'll talk about where that asymptote goes. A square inverse also has an asymptote, but both of its branches are positive because squared things are always positive. That was not a very good drawing. Okay, so it's above the x-axis. Okay, so thinking quadrants, a hyperbola would live in quadrants 1 and 3. A negative hyperbola would live in quadrants 2 or 4. So if you want to do that, there is a negative option to this. The negative option would be like that. That would be the negative one. So that's negative. This one's a positive one. For a squared inverse, the positive one is above the x-axis. The negative one would be upside down from that. And then we have the last set of cousins. Okay, exponentials and logs are similar to each other. They also have asymptotes. An exponential, I was alluding to that earlier, has a horizontal asymptote, and the graph, it's usually at the x-axis, and the graph hugs till it hits that critical point, which is on the y-axis at 1, and then heads up to infinity. So that's what an exponential looks like. Starts out very, very slow growth, and then has rapid growth very quickly. If you turn that sideways, you get a logarithm. The logarithm then, if you turn it sideways, would have a vertical asymptote, and it starts out hug, and then it shoots off more in a sideways direction instead of an up, and it also goes through that critical point. That's just a sideways version of it. So all I need is for you to just have a working, like, picture knowledge that you could picture in your head kind of what that's doing. Because I might say, is it going up? You know, what direction is it headed? Okay, how things get made upside down is with a negative number. So if you want to make something go upside down over the x-axis, the negative goes on the outside. Okay, so whatever, if you have a square root and you want to make it go upside down, the negative goes on the outside. If you have a logarithm and you want to make it go upside down, or an exponential, the negative goes on the outside. If you want to make something reflect over the y-axis, the negative goes on the inside. Okay, so what I'm talking about is like a negative square root x versus a square root negative x. Where is the negative positioned? Okay, if you want to make a sine graph go upside down, you put the negative on the outside. If you want the sine graph to be reflected sideways, then you put it on the inside, so sine negative x. If you want to translate a whole graph to the left, you're going to add. It's backwards of what you think. And when you want to translate it to the right, you're going to subtract. But again, those are both inside the function. Okay, so I'm talking about square root of x plus 2 or the square root of x minus 2. That's both called inside. And one of them is going to take them to the right and the other is going to take it to the left. If you want to translate something up, you add, but you add on the outside. And if you want to translate something down, you subtract, but you subtract on the inside. So where does that plus 2 or minus 2 go? It would go at the tail end of your function. Okay, square root of x, and that square root is ended, and then at the end of the function, you would have a plus 2 or a minus 2. Okay, any questions about that? Yeah?
So when you want to make the graph go down, you subtract on the inside too?
No, if I want it to go down, I would say the square root of x, and then I would have minus 2 clearly on the outside of the function, as opposed to the square root bar like covering that over. Okay, so that would make it go down. All right, so let's just review what I would want you to know. What can you tell me about the top f of x function? What shape is it?
Parabola.
It's a parabola. Okay, it starts out with its vertex on the origin and opening up. Okay, what's happening to it? What does the plus 2 do? 2 left. Okay, what does the minus 3 do?
Down.
2 down. So all I want is for you to get that spot in the right spot, 2 left, 3 down, and then draw me a parabola that opens up. Okay, but I'm not going to like be counting your squares and make sure that it's opening up in the right amount of, width or whatever. Okay, the domain of that is all real numbers. The domain is because it doesn't have a division, it doesn't have a logarithm, it doesn't have an even root, so the domain would be all real numbers. Now the range. Okay, the range for that function, because it ended up over here down to, over to down 3, because it ended up down there, the lowest point of that graph, is negative 3,
Sorry, I forget, how do you know if it opens up or down again?
Oh, it's just positive. There's no negative in the front of it. That's called a reflection. And so if I wanted it to open down, there would be a negative in front of that x squared. All right, so my range goes from the lowest point to the highest point. So for range, you would write, I kind of call it, a betweenness for y. The lowest value of y is negative 3, inclusive of negative 3, because it hits negative 3, that's the vertex. And the highest point that it will get to is positive infinity, because it's just going to keep going forever. Okay, so that's one way to write the range. You could also write it with the interval notation, negative 3 with a bracket to show that it's inclusive of negative 3, and then infinity with a soft-sided parenthesis to show that it will never arrive at infinity. It will keep going on and on and on. Okay, the last way you could write it is to just leave off the infinity altogether if you're writing it with the inequality notation. Okay, so you don't need infinity if you use the inequality notation. It's implied that infinity is there, but if you use the interval notation, you've got to have the infinity as your second part.
Does it matter if you would write y is greater than or equal
No.
to 3 infinity?
No. Okay, so he's saying, could I say this way? Sure, for sure. Okay, and then the other function would just be the absolute value. Good, that was it.